Welcome back for video 2 on waves. We're going to do harmonics on guitar strings or just regular strings, and then we'll be starting to look at mass spring systems. So if this is a string, maybe on a guitar, we're going to notice a pattern where we have two nodes here. It's a place where vibrations cannot occur. And in the middle, we'll have a very large vibration. So just imagine a string vibrating back and forth. And here's our pattern for the wave. And this is for the first harmonic. And what we notice is there is a node and a node and an antinode in the middle. So that is half of a wave. So this is length L. L equals 1/2 of lambda. So lambda then is equal to 2L. So we can derive our frequency patterns here, okay, because frequency times wavelength is equal to the speed of the wave. So frequency then is equal to the speed of the wave divided by lambda. We know lambda is 2L, so our harmonic pattern then becomes frequency equals NV divided by 2L. And N in this case is 1, 2, 3, etc. because we're starting with half of a wave inside the string. That's unlike our graduated cylinder that we saw in the last example. Now what if we let N equal 2? Well, plugging in 2 here, 2 over 2 does cancel out. Therefore, we should have one whole wave then inside our string. So let's look at that. So we have a node here, and then we have a node here. We're going to end up with another node in the middle, and we got to have to end an antinode as well. So what does the pattern look like? Well, it's going to vibrate like this, back and forth here on either side of the node, and likewise it's going to vibrate back and forth here. Let's make that a little better there. So our pattern this time is going to be node, antinode, followed by a node, and an antinode, and then a node. And see how that's one full wave oscillating in there. So that would be the pattern for the second harmonic. The third harmonic, we would have to put another node and antinode in here, and we'll have 3 halves of the wave in the string. And then the fourth harmonic, we would have 4 halves, which would be 2 whole waves, because you'd need to put another node and antinode in there. And each time the frequency goes up. Specifically, the fundamental frequency, or n equals 1, when we go to the second harmonic, we have doubled the frequency, and we have raised it by 1 octave, the pitch by 1 octave. And that's how standing waves are done in strings. Our next example is a mass spring system. I've got a mass attached to a spring, and we're going to stretch the spring. It's going to oscillate back and forth. And we'll assume that there's no friction associated with it. We can get the period of the oscillation from this formula. The period is equal to 2 pi times the square root of the mass divided by k. And then we can map that time here. So let's go ahead and do that. The time is equal to 2 pi times the square root. We have 250 grams. That does need to be in kilograms. 250 divided by 25. And that equals 0.63 seconds. Now we want to graph amplitude versus time. And we also want to graph velocity versus time and acceleration versus time. And it's a pretty easy graph for us to do. We do know that the total time is 0.63 seconds, so I guess I'll put a little mark here at 0.63 seconds. And then the half mark is about 0.31 seconds. And of course we have the fourth mark in between. Okay, so when we pull this mass spring system, we'll say we pull it this far. It will go here and it'll oscillate back and forth between these two lines then. Back and forth here. Okay, then we'll start with an amplitude. Let's call this direction positive, that direction negative. So our amplitude maximum here and amplitude minimum is going to be from the 0 line. So let's just put a little line here and call that 0. So if I pull this 5 centimeters, my amplitude will be 5. And then it'll go back and forth to 0, and then this will be negative 5. Okay, so we're actually starting then at 5 centimeters here. It'll then oscillate back to 0 at 1/4 of a wave. And then at a half of a wave, it'll be down here at negative 5. And then back here at 3/4 of a wave. Okay, and then finally returning to its original position here. And we see that that is a cosine wave, and I'll try to connect my dots well there. Okay, so that's the beginning, okay, of the wave. And the next video, we'll pick up the velocity and the acceleration versus time.